All right, this is our video on how to solve solve word problems using a system of equations. So there are some problems that really lend themselves to setting them up as systems, and they usually involve two different facts, essentially. So as with any word problem, we're going to set up our three columns, all right? But in this case, I'm going to make the second column as wide as I can. Really going to make it really wide, because we're going to solve a system of equations in there. So if you take a look, if we read this through, there are going to be two facts about two different numbers. So the first fact is the sum of two numbers is 28. The difference of the same two numbers is 4. And if we read this, it's not like we have, all right, something like the second number is twice, is 5 more than twice the first number. What we have is two facts about two numbers. Neither one of them is like at the end of the sentence. So what we're going to end up doing here is we're going to make two variables up. So I have two numbers, and I know two facts about them. So I want to say x is the first number, and y I'll call the second number. And I know two pretty simple facts about them. I know that the sum of the two numbers is 28. So I can write that as the sum of the two numbers. The two numbers are x and y. The sum would be when I add them up, I get 28. Then the next fact is that the difference of the same two numbers is 4. Well, the difference of the two numbers is when I subtract them, I will get 4. So I'll take x and I'll subtract y and I'll get 4. And what's nice about this is I get a very nice, easy system of equations to solve. And I can actually find the two numbers. So if you tell me two clues about two numbers, I can find them. The two clues being the sum of the first two of the two numbers is 28, and the difference is 4. This system is already has opposites in the y's. So I'll just use my elimination method. X plus x is 2x. The y's cancel, and 28 plus 4 is 32. Divide by 2, and x is 16. But I want to find what are the two numbers. Well, I know x is 16. That's one of them. And how would I find the other one? Well, I can do it a couple of ways. I could take this equation, for example, x plus y is 28, and plug in 16. Because I know 16 plus it is 28. The sum of the two numbers was 28. And I'll subtract 16, and I'll get y is 12. So I know the two numbers are 16 and 12. And if I add them, I do indeed get 28. And if I do 16 minus 12, the difference, I do indeed get 4. So we found two numbers whose sum was 28 and whose difference was 4. All right, next one. We have a problem about Dean and Bradley here. Dean and Bradley are such nice boys, and they bought flowers for their mothers for Valentine's Day. Dean bought 6 roses and 6 carnations for a total of $45. Bradley bought 8 roses and 4 carnations for a total of $48. And we want the cost of a rose and the cost of a carnation. So again, similarly to problem 1, we were given two facts, the yellow fact and the green fact. We're given that same situation here. We're given two facts. We're given this yellow fact. Dean brought 6 roses and 6 carnations for a total of $45. And Bradley bought 8 roses. Whoops, sorry, I meant to do that in green. Bradley bought 8 roses and 4 carnations for a total of $48. And we're talking about two different objects. The cost of a rose and the cost of our carnation. Similarly, as in the first problem, we were talking about two different numbers. So I'm still going to set up my word problem. I want to make that second column wide, and you'll see really where that comes in on this one. But I'm going to apply my variables into terms of what they're asking. So I want to say, let R be the cost of 1 rose. Okay? And this is in dollars, okay? It's in dollars. I have a little dollar sign there. And C is the cost of a carnation. which is a type of flower. And I want to put a little dollar sign to remind me that it is, in fact, a cost of something, because you're going to see how that works out in a minute. Now, if I buy 6 roses, and each rose costs $2, I would multiply 6 times 2. So to get the cost of 6 roses, if each rose costs R dollars, I'm going to write 6R. So right now, we're translating Dean's sentence or fact into algebra. So 6 roses, the cost of that would be 6 times R. And R is coming along with its dollar sign. So right now, 6R is in dollars. 6 times the cost of a rose is going to give you the cost of 6 roses. Plus, similarly, we're going to do 6 times C, which is also in dollars. And that equals 45, which is also in dollars. Dollars plus dollars makes dollars. All right? This isn't about the number of roses. It's about the cost of each rose. Now we're going to do the same thing with Bradley. Once we do Dean's setup, Bradley's is easy. He bought 8 roses, so that's 8 times the cost of a rose in dollars, plus 4 carnations. Okay, 4 times the cost of a carnation is going to be a dollar amount, and that totals up to $48. Whoops. I'm just going to make this a little smaller. Okay, that didn't work out, so hold on a second. Group these all together, shrink them a little bit. Okay, perfect. Now, we want to find the cost of a rose and the cost of a carnation, and I hope you see that we get a very nice system of equations. So what I would like to do is I'll eliminate one of the variables. So I'm going to eliminate C. So I'm going to multiply the top equation by the 4 in front of the C on the bottom, and I'll multiply the bottom equation by 6 from the top. And we're going to distribute. So 4 times 6 is 24. So we get 24R plus 4 times 6 is another 24. 24C equals 45 times 4 is 180. And then we'll do the same thing with the bottom. We'll distribute the 6 through. So the numbers might get a little big here, but that's okay. 6 times 8 is 48R. 6 times 4C is 24C. And 48 times 8, see if I can do this in my head. 40 times 8 is 320. 8 times 8 is 64. So that would be 384. Okay. Now, we don't have opposites yet, but the 24s are the same number. So I'm going to take, I'll take the bottom equation and just change all the signs. So I'm going to make the 48 a negative. I'll make the 24 a negative, and I'll make the 384 a negative. And then I'm going to add down. 24R minus 48R is negative 24R. The 24C and the negative 24C go away. And 180 minus 384 turns out to be negative 204. Divide by negative 24. And R turns out to be, I believe, a decimal. So let me get my calculator up here. I don't feel like doing long division. Neither do you. And wait and wait and wait for this calculator to load up. In the meantime, we're going to get R, the cost of a rose is something, and then we can plug back in to get the cost of a carnation. And then we'll be set, and Bradley and Dean will know how much money they have to save for their mothers for Valentine's Day. So let's take a look here. Okay. Okay, whoops, the wrong button. There we go. Okay. So here's what we have. I have to do negative 204 divided by negative 24. And that gives us $8.50. So a rose costs $8.50. Because let's keep in mind, the rose, the R is the cost of the rose, not how many roses you're buying. So there's R. And now I can plug back into any original. So the cost of a rose was $8.50. And now I want the cost of a carnation. So cost of a carnation, I'll do the work down here. I'll take the blue equation, doesn't really matter. 6 times the cost of the rose, which we just said was $8.50, plus 6C is 45 bucks. So 6 times 8.50, we need that number. 6 times 8.5 equals 51. All right, boys and girls, I made a mistake, but I want to show you something, okay? I made a mistake, and I'm not going to go back and change the video because I want to show you something. 6 times 8.50 is actually $51, okay? So this is 51 plus 6C is 45. And if I subtract 51 from both sides, I'm going to get 6C is equal to negative 6. And I'll divide by 6, and I'll get C is negative 1. Well, that's a problem, because the cost of our carnation can't be negative $1. Okay, so this is wrong. I'm going to erase this. And I made a mistake that's easily fixable. And the mistake I made was I made an error. I multiplied wrong in my head. So that's what happens when you do stuff in your head. This should have been 6 times 48 is 288. So we get negative 288 there, and we'll fix this up. So 180 minus 288 is negative 108. Divide that by negative 24. Let's try this. Negative 108 divided by negative 24 gives us 450 for a rose, which is much more reasonable anyway. And now we'll get the cost of a carnation. So sorry about that. 6 times 450 plus 6C is 45. So 6 times 450, a lot more reasonable. That equals 27. So 27 plus 6C is 45. Minus 27 on both sides. So then 6C, 45 minus 27 is 18. Divide by 6, C is 3. So a carnation is $3. And so now we have our answers. Okay, so the cost of the rose is not $8.50, it is $4.50. And the cost of a carnation is $3. We're going to do one more. All right, for this video, skip to number 4, please, which is an interesting one. It says, Allie has $1.25 in her pocket. The money is in quarters and dimes. So she's got some amount of money in quarters and dimes. There could be many possible combinations. But we know there are a total of 8 coins, and we also know that Allie has $1.25 in her pocket. And the question is, how many quarters and how many dimes does Allie have? So the question is a little different here. It's not how much does a quarter cost. We already know that, or how much a dime costs. It's how many quarters and how many dimes does she have. So I'm going to let Q be the number of quarters that Allie has, and D be the number of dimes. Now, there are 2 facts. One fact is a money fact. Okay? There's a money fact. So when I write this, I'm going to write money here. And then the other fact is not a money fact. What I mean by a money fact is it's not a dollar amount. Maybe I'll put dollar amount here too, to distinguish between that. The other fact is not a dollar amount fact. It's a number of coins fact. Okay? There are a total of 8 coins. So we have quarters, the number of quarters represented by Q, the number of dimes represented by D, and the total is 8. So my number of coins fact is the number of quarters I have plus the number of dimes that I have equals 8. And these are numbers. Okay? This is a number fact. Now, above I'm going to get a money fact. How do I get a money fact though? Let me do a little side note here. If I have 3 quarters, so I have 3 quarters, how much money do I have? Well, I don't have 3 in terms of money. I have 0.25 times 3. I have 75 cents or 0.75. So if I have Q numbers of quarters, I have 0.25 Q amounts of money. So when I do the money equation, I'm going to multiply the Q by 0.25, and I'm going to multiply the dimes, the amount of dimes that I have, by 0.10. So a dime is worth 10 cents. And now I will have a total of $1.25. And notice, 25, that's a dollar amount. 0.25 is a dollar amount. 0.10 is a dollar amount. 125 is a dollar amount. And now we have a money equation and a number of coins equation. So it's just a matter of making sure that you just don't put Q plus D as 125. That's not true. Q and D are the numbers of coins that you have. You can't have 0.25 of a coin unless you broke the coin, which would be kind of awkward. So now we have the system of equations. So I'm actually going to expand my third column here a bit. Sorry, the second column a bit. And so I'm going to shrink these equations down because we need a little room here. So, swoop. There are my 2 equations. And now we got to figure out what's happening here. So I'm going to eliminate dimes, okay? There's a 1 in front of the D here. There's a 0.10 in front of the D there. So the top equation will get multiplied by the 1. The bottom equation will get multiplied by the 0.10, okay? Now we'll distribute. 1 times the top equation is just the top equation. So we're going to get 0.25Q plus 0.10D is 1.25 again. Now on the bottom equation, we're going to multiply through, and we're going to get, 0.10Q plus 0.10D is 0.10 times 8 is 0.8. Oh, 0.8. Now, we've created 0.10D and 0.10D. They're not opposites yet. So I'll take one of the equations, and this time I'll do the bottom again, and I'll change all the signs. So positive 0.10 becomes negative, positive 0.10 becomes negative, positive 0.80 becomes negative. And now we can add down. So 0.25 minus 0.10 is 0.15 Q. The 0.10Ds cancel, and I get 125 minus 80, which is going to be 0.45. And now I'll divide by 0.15, and I'll get my Q to be 3. So now the number of quarters I have is 3. And if we put that on the side for a minute, if I have 3 quarters, I've got 75 cents so far. Okay? Or maybe I shouldn't write it like that. I'll write it as 0.75. Now I need the number of dimes. So I'll go back to my original system that I set up. I'll pick the Q plus D equals 8, because that's easy. Q plus D, actually let me do it over here. So now we're going to plug the quarters back in. And so Q plus D is 8. 3 plus 5 is 8. Sorry. 3 plus D is 8. I had the answer in my brain, and I just wrote it out. And so we'll subtract 3, and D is 5. Just as a quick check, if you have 5 dimes, well, that's 50 cents. Or 50 cent if you like wrappers. So 0.75 plus 0.50, if you add that up, you will get $1.25 out of your 8 coins. So it kind of checks that we have $1.25. And so the final answer would be we have 3 quarters and 5 dimes. And that's it. And I think with those three problems, you'll be able to do any others.